I'm Ellen Crocker, Forest Health Extension at the University of Kentucky.
And I'm Lee Moser, a Water Quality Extension Associate here at the University of Kentucky College of Agriculture, Food and Environment. We're here today to tell you a little bit about the Steam Weeder project that we've been working on for the past several years.
The Steam Weeder is a new piece of equipment that we've been testing out in a variety of contexts to control vegetation. There are lots of tools in that toolbox, but also a lot of need there in different contexts, whether it's managing invasive plants and getting rid of those, to managing the weeds that pop up in your mulch beds.
So the reason we're working with the Steam Weeder is because it's been identified as a potential alternative to traditional herbicide use in potentially sensitive areas like adjacent to streams and waterways, or near storm drains, or impervious surfaces where it may be prone to runoff.
Whether we're talking about your garden, a landscape, or a natural area, there's lots of reasons that you might need to manage vegetation. There are invasive plants that come in, there are weeds that pop up, and it's important to have a big toolbox to deal with those different problems. You can always use mechanical removal, pulling things up. There's chemical removal and effective treatments with herbicides. But we hope that the Steam Weeder could be another tool in that toolbox. Might be a good fit for certain settings.
The Steam Weeder project was funded by a stormwater incentive grant provided by the Lexington-Fayette Urban County government.
In addition to us, this grant was first acquired by Dr. Carmen Agaritis at the University of Kentucky and Dr. Greg Munshaw. They worked with UK's Physical Plant Division, Stacey Borden, Jerry Hart, and Richie Katko to conduct this work on campus.
The staff at the Arboretum also played an important role in conducting the research. So you might be asking yourself, what exactly is a Steam Weeder? So a Steam Weeder is a device that uses a diesel burner and a pump to generate saturated steam. At the machine, it's running about 250 degrees Fahrenheit, and at the point of application, it's about 205 to 218 degrees Fahrenheit. And the idea is to basically scald or steam the vegetation on site as an alternative to traditional pesticide that you might experience things like drift or potential runoff and contamination of local waterways. So steam weeding technology has been used in larger agricultural operations for some time, and it's just now starting to become commercially available in a way that can be mounted to a trailer and used in settings like here at the Arboretum. So we've been using it here at the Arboretum to try to test its potential for eradicating winter creeper. We've also been testing it for its potential for collateral damage when you apply near ornamentals like yews or lilies. So now Richie Katko is going to show us how to start up and operate the unit in the next video clip.
This is our steam machine, the Weed Technics steam generator. It uses a diesel burner here to create steam, and then uses a gas pump to push steam through the hose and out the system. So it's got 5 fluids that we monitor. It's got water, of course, in the yellow tank in the back. We've got 2 diesel tanks here that provide the fuel for the heat and the burner. And then we've got gasoline that runs a gas pump that pushes water through the system. And then we've got oil in both the diesel burner as well, so we have to monitor oil in the gas engine. That's our 5 fluids. We've got controls to turn on the burner. We've got controls to change the pressure of the system. I've got controls to change the temperature of the burner, and I've got controls to operate the gas pump. We've got to deliver the steam, we've got a traditional sort of pressure washer nozzle, or gun, if you will, with a trigger that controls steam delivery. So one of the first things we do when we operate is we flush out the system from the last time we use it. To do that, we would unspool the hose, and we would turn on the gas pump and run the gas pump for about a few minutes. We see a change in the color of the water from a blue to back to clear, and that's when you know that the system is flushed. Once the system's flushed, the pump remains on, and you would turn on the burner itself. Once the burner is on, you wait a few moments and can look at the temperature gauge and watch the temperature rise. When we operate, our biggest concerns when we're operating are running out of gas in our water pump and running out of water in our tank. We get about 2 hours of use out of a tank. if we run out of either gas or water, we run into a problem. We can't flush the burner with cool water to cool it down, right? We have to have cool water left over, so no matter what, we leave enough water, maybe 10 or 20 gallons of water, and we leave enough gas in our pump to be able to effectively flush the system every use. So after we would cool the system down, we would spool the hose back up, remove the nozzle heads, and do a walk around, pull our cones, make sure we're ready to go. You know, that's how we can operate in a day. After we do all of our safety walk-arounds and checks, you know, we can unspool our hose here, kind of keeping it protected. So unlock the spool. Start pulling some hose out. Try to minimize dragging the hose on the pavement or snagging the hose. Then we can turn the pump on and we flush the hose in a safe place, maybe into the ditch or water a plant or something with the water. Got a typical gas pump here with a ignition, key ignition this time. We don't have to pull the pull start at all, which is awesome. So one of the first things we'll do is we're going to turn the fuel on. After checking the fuel level, of course. Let's see while we do that. Good. Check the oil. We check the oil here. And then we can start the pump. So we've also got water, our water tank, and we have the water is turned on, which is important because we're trying to pump water. So we'll turn the gas on, and we'll notice we've got the engine choked, and then we'll turn the on switch after putting on hearing protection because it's loud.
So like anything, the steam weeder has some pros and cons that we should probably share with you.
Some of the things that we noticed in our testing that we were surprised by, in a good way, was that first, it was really effective. We tested it on winter creeper, which is a really challenging to manage invasive plant. It grows kind of over things as a carpet, it's woody, it has this really thick waxy cuticle on the leaf that makes it hard for it to take up different herbicides. But the steam weeder was really effective. In our tests, it was on par with another herbicide that we tested. And I think could be really effective in certain settings on a wide range of weeds and other plants. In addition, not only was it effective against winter creeper, but it didn't impact the plants that were directly next to it. So you can really limit your potential for non-target impacts. It's not going to damage the plants that are next to what you're trying to kill.
So as for the downsides of the unit, there are a couple of major ones that we should probably identify. The first being the fact that it's probably cost restrictive for your average homeowner to purchase one of the units like what we have tested here on campus. This one ran about $12,000, and this might be more appropriate for, say, a landscaping operation to use as an alternative service, or in the context of a grounds department at a university or in a municipality. However, we didn't really find any units that were cost effective for a homeowner. Hopefully that'll change in the future, but at this point we haven't really identified any to share with you all. The other major challenge associated with the unit was the amount of time that it takes to control a plant such as winter creeper. In a stand like this, where it's really dense and widely spread throughout a forested stand, we were using an application rate of about 2 to 4 seconds per linear foot of winter creeper, with about a 1 foot wide applicator head on the steam weeder device. So if you do the math, that adds up to a lot of time in an area that may be more appropriate for an herbicide to control the plants that you're trying to remove.
While some of our trials were here in this woodland setting, it's probably not the best use case for the steam weeder. But nonetheless, I think they prove some of its potential benefits in a range of different landscape settings. Thanks for joining us today and learning a little bit more about the steam weeder and the University of Kentucky being a living, learning laboratory for all sorts of research. If you want to learn more about managing invasive plants or other unwanted weeds in your landscape, make sure to reach out to your county agent. They're a great resource, and you can also check out this link to learn more about the steam weeder in particular.